All right, Algebra 1. We skipped 10(1) because that's just about -3 is less than 5. And I'm thinking you guys are probably pretty good with that. So we are moving on to lesson 10(2), and now we're using those inequalities and we are solving them like equations. So you're going to find this very similar with a couple little changes along the way. Our essential question is, can you transform inequalities in order, there we go, in order to solve them? So let's hone in here on the property comparison. It says for all real numbers a and b, one and only one of the following statements is true. A can be less than b, a can be equal to b, or a can be greater than b. Suppose you know two facts about the graphs of three numbers, a, b, and c. The graph of a is to the left of the graph of b. Therefore, a is less than b. The graph of b is to the left of the graph of c. Therefore, b is less than c. From the graphs above, you can see that the graph of a is to the left of the graph of c, so a is less than c. The facts above illustrate the following property. This is called the transitive property. The transitive property of order tells us that if all real numbers a, b, and c, if a is less than b and b is less than c, then a is less than c. If c is greater than b and b is greater than a, then c is greater than a. So what happens when the same number is added or subtracted from each side of an inequality? If I have 3 is less than 6, and I add 4, what I do to one side, I do to the other, notice 7 is still less than 10. And the same thing with subtraction. If I subtract a -4 to each side, I still have -1 is less than 2. These numerical examples suggest the property of order stated on the next page. Well, we don't have the book with us. That was just a little insert from the book. So let's go ahead and let's talk about how to transform the first inequality into the second. So what I tell my students is, hey, we're going to look at this just like we would at solving equations. Let's pretend that this is an equal sign. How would I get rid of the 8? I would subtract it. So what I do to one side, I do to the other, and t is greater than 24. So if I had to tell how to transform it, I would subtract 8. So this brings us to the addition property of order. It says for all real numbers a, b, and c, if a is less than b, then a plus c is less than b plus c. If a is greater than b, then a plus c is greater than b plus c. Now, something's going to happen when I switch it to multiplication. What happens when each side of the inequality is multiplied by a non-zero number? So I'm going to tell you to star circle highlight because this is the one thing you need to realize. Okay? I know that when I multiply a number by 2, they're telling us that -4 is less than 3, which we know is true. And when I multiply each side by 2, what I multiply to one side, I multiply to the other, that statement holds true. -8 is less than 6. But when I multiply by a negative number, notice that statement is not true. So I'm going to do that up here. If I multiply each side by a -2, I no longer have a true statement. 8 is not less than -6. Therefore, I have to flip the inequality. So I know that 8 is greater than -6. So my star circle highlight here is we always want to flip the inequality when multiplying or dividing by a negative number. So let's look at example 2. Again, we're going to look at this just like it's an equation. So I want to get rid of this 2 first by subtracting it. What I do to one side, I do to the other. -3x is greater than or equal to, well, 8 minus 2 is 6. Now, in order to solve this, I have to go ahead and divide by a -3. So remember, when you're multiplying or dividing, I'm going to start again. When multiplying or dividing by a negative, we have to flip the inequality. So when I divide by a negative, I know, I'm going to write this over here, that x is less than or equal to -2. So this inequality is greater than or equal to, and I just flipped it. Now the directions tell me to solve and graph, so I'm going to go ahead and graph this inequality. And we're just going to graph these on a number line. You guys have been such good graphers. And remember, we're just going to take a -2. Because it is less than or equal to, and equal to, we're going to fill in the circle. I'll take notes on that in just a second. And if x is less than, that was a really messy less than. If x is less than -2, I'm going to shade down this way to the left because all these numbers are less than. All right, so let's take a note. If I have less than or greater than, we're going to have an open circle. If I have less than or equal to and greater than or equal to, we're going to have a closed circle. All right, we've learned a lot. Let's see if we could do one more inequality. Wow, this one looks long. So the first thing we would do in example 3 is we would probably distribute, right? We would probably have to distribute. So let's do that first. I have 2y minus 4 plus 25 plus 5y is greater than or equal to 0. Distribute. When I add like terms, 2y and 5y is 7y. Add like terms, -4 and positive 25 is positive 21 is greater than or equal to 0. Continuing to solve, when I subtract 21 to each side, I get 7y is greater than or equal to -21. I am dividing by a 7. This is not a negative number. Even though the 21 is negative, we are not dividing by a negative number. So I'm going to cross out the 7s, and I'm not going to change the inequality. And we know that y is greater than or equal to -3. So will I have an open or closed circle on -3? I'll have a closed circle. And if y is greater than, the numbers greater than are going to go this way. And notice I graph them above the line. I know some of you guys graph it right on the line, but it's hard to see sometimes with a pencil. So just make sure your math teacher can read it. Great job.